Okay, so previously we went over the magnitude of vectors. Now we can go over how to find the direction or the angle or the angle of vectors, right? So let me just draw a quick diagram to demonstrate this. Let's say this is my Cartesian plane, and then I have a vector OQ. So this is Q and this is O. Let's say the vector OQ is given by 3i, let's say, and then plus 4j, right? So it is going horizontally by 3 and vertically up by 4, as you can see, right? So how can I find the angle, which is this, theta, right? If I wanted to find this angle, you can see, just using normal trigonometry, tan theta equals to opposite over adjacent, right? Opposite over adjacent, which is y over x. So this is your formula to find your angle, right? And then to find the actual angle, you can do theta equals tan inverse of y over x, right? So if you tan inverse both sides, this tan just goes away, and you're left with this result, right? So this is how you find theta. I should also mention that this theta is the angle measured from the horizontal x-axis and then read anti-clockwise, right? What I mean by that is, let's say I had a vector like this. The angle I'm trying to find is not this actually, it's read from the positive horizontal x-axis, right? So a vector like this, I would be finding this as the angle. Let's say I have a vector like this. I read it anti-clockwise from the positive horizontal axis. So I'm trying to find this theta pretty much, right? So I'll give like a fairly quick example. So let's say I have OB, a vector OB example question, and this is 7i and then, actually no, negative 7i plus 3j, right? And find what the theta is. Okay. Maybe we should highlight this. Direction and angle of vectors. So if I just use the formula from before, you have tan theta equals to y over x, right? So this is my y, which is 3, divided by x, which is negative 7 in this case. Negative 7. So theta equals tan inverse of 3 over negative 7. If I quickly put that in my calculator, so just remember to keep it in degrees mode. So tan inverse of 3 over negative 7. HSC. Wait, 3 and 3 negative 7 as your answer. Okay, so just remember for your HSC graph when you do this, right? So when you actually put tan inverse of 3 over negative 7, you can see your angle that you get is 23 degrees 11. Oh wait, negative 23 degrees 11, right? But if you think about this logically, I should also probably add that this angle is always between 0 and 2 pi, and 300 or 0 and 2 pi, or 0 and 360 degrees, right? It means the same thing. So you can see you can't have a negative number. So if I look at what 3 over negative 7 actually looks like, my vector, so negative 7, right? So this is negative 7 horizontally, and then 3 vertically. So my vector actually looks like this, right? OB. So your answer should be something like, let's say, a bit more than 90, and then less than 180. As you can see, it's somewhere in this quadrant, right? What you can do is, if you use your ASTC graph, I can see that for tan theta, I get a negative value, right? Which means that if it's negative, it cannot be in here, cannot be in here. It has to either be in S or C, right? Because that's how ASTC works, right? Remember, A means sine, cos, and tan. All of them are positive, right? Cos means cos is positive, sine is negative, tan is negative. Same for the other ones, right? Sine is positive here, tan is positive here. So if tan is negative, that means it has to be either this one or this one, because it's positive here and here, right? So what you do when you have something like this is, my relative angle in this case is 23 degrees 11, right? So when you find relative angle, it is just the relative angle is the acute angle that you get as an answer, right? So it doesn't matter if it's negative or positive, I just care if it's acute or not, and I'll use that to basically find my answer, right? So when you use your ASTC graph, you have something like this actually. 180 minus theta. 180 plus theta. And this is 360 minus theta, right? And this theta in this case is, I'll just call it here. So this theta that I'm using is my relative angle. So when you find a relative angle of 23 degrees 11 minutes, if I know it's either in S or C, you can see it's going to be in S, right? Just visually, it's somewhere here, so it has to be in S. If I wanted to find the actual angle, I can see it's in this quadrant, so I'll use this formula, right? 180 minus theta. If it was in C, for example, then I'll use this, right? 360 minus theta, which is 23 degrees, right? So if you put in your calculator, 180 minus 23 degrees, your actual angle for this question is going to be 156.48, right? So if you're not 100% sure, you can try typing in tan 156.48, and you can see you get negative 0.4286. If you type in 3 divided by negative 7, it is also the same answer. So you can see it works, right? So this kind of topic requires like a fairly good understanding of how the ASTC graph works from previous years, right? Some people like remembering it as all stations to central. Okay. Seems like I spent a bit too long explaining that. But if we move on, vectors, I can also break into components, right? So components of a vector. Basically, I can break a vector into something like this. Let me draw another diagram, right? So I know already that if I have a vector, it can be written like this. So let's say I have a vector P, which is how do I say this? X and then I plus y, j, right? So if I have a vector P like this, if I wanted to find what the x and y coordinate are, what you can actually do is x1 equals, if I wanted to find what the x and, okay, so if you want to find the x and y components, if only given the vector length and angle, so let's say this is theta, and I don't know, let's say the length of P, so the length of P is 7, right? So if you only know these, okay, and then let's say the theta is 30, right? If I only know these two pieces of information, how can I write it in this notation, right? So I don't know what my x is and I don't know what my y is. So how can I figure it out? So if you just think of regular trigonometry, you can see to find the x, this is my adjacent, this is my hypotenuse, and this is my angle, right? Adjacent and hypotenuse. And remembering that cos theta is adjacent over hypotenuse, right? You can see that cos 30 equals to adjacent, which is my x axis, so x over the length of p, right? So the length of p, which is 7 in this case. So I'll just write 7 actually. Oh, length of p, which is x over 7. And I can do the exact same thing for the y-coordinate, right? So if I know that sine theta equals to opposite over hypotenuse, right? So opposite over hypotenuse. I can see that opposite is my y, hypotenuse is the length of p, right? So if I write sine 30 equals to opposite, so y over p, I can see that equals to y over 7, right? If you simply rearrange now, if I highlight this, if you simply rearrange for x, you can see that you get 7 cos 30, right? If I times both sides by 7, if I look at this, right? 7 cos 30, and the same for y. Y, I get 7 sine 30, okay? So that was just like an example, but the general result looks something like this. Your x will always equal to the length of the vector cos theta. The y is always the length of the vector sine theta, right? So I'll just write this here. This is the length of the vector, and then theta, remember you can, well, I mean, if you're given theta, then that's how you would figure it out, right? So this is just something that is required to know. I'll just put it in a box. Okay. Okay, so moving on from this, I'll try like an example question, and then you can try a similar example question afterwards. So let me just write out. Okay, so it's already given me the two useful pieces of information, right? The length and the angle. So if I scroll back up, I want to find the length and the angle. I mean, no, but they've given me the length and the angle, and I want to find what the vector actually is, right? So if I just simply use the result that I have here, remembering that in component notation, the vector is written as this, yj, right? So my x component I can see is the length times cos theta, right? So you have the length, which is 10, cos 150, and that is your I component, right? So how far it goes in the x direction. For y, you can see it's just the length times sine theta. So the length is 10, and sine 150, right? And then j. So simple as that. It's fairly simple. Just remember, for things like this, whenever they have something like sine 30, 45, or 60, or anything like that, remember they want you to write in exact form, right? So again, using your ASTC graph, cos 150 is somewhere here, right? So 150 degrees is there. If I want to find an equivalent angle, so cos 150 is going to be the same thing as negative cos 30. Why? So cos 150, I can see it's in the S quadrant, right? So if it's in the S quadrant, it's going to be negative. And remember, the relative angle is just going to be the acute angle version of this thing, right? So 150 degrees, I can see the acute angle is this thing here, right? So 30 degrees, that's how I get this. And the negative just comes from the fact that it's in the X quadrant, right? If I do the same thing for sine 150, I can see sine 150 is already positive in S, right? Which means that when I find the relative angle, which is still 30, right? Then it's going to equal to sine 30. So I don't need the negative because sine is positive in both this quadrant and this quadrant, right? Cos is negative in this quadrant and it's positive in this quadrant. So what you can do now is I can write this as negative 10 cos 30 I plus 10 sine 30 j. And if you're not too sure about the exact values, you can quickly search it up and it will give you a table. But for cos 30, you should have 5 root 3, I believe. So when you simplify this, you get negative 5 root 3. Yep. 5 root 3 I. And then for your y coordinate, it should be 5j. So if you're not too sure about how I went from here to here, you can simply just check the exact values table, right? So if you search it up on the internet, it should look something like this: 30, 45, 60. And then they should have a bunch of values in the tables that you simply just need to memorize, but it shouldn't be too bad. So I'll write another example that you can just try. So do the same thing for a vector where the so do the same thing for a vector where the length is, let's say, 5 and the angle is 30. Okay, so let me just draw this graphically so you can see it. So the length is 5, the length of V is 5, and the angle is 30, right? So if I wanted to write this in x and y components, you can see the x component is just V cos theta, which in this case is 5 cos 30, right? And the y is V sine theta. So I'm simply just using this formula from before, right? V sine theta, which in this case is 5 sine 30, which should give you 5 cos 30. Wait, cos 30 is root 3 on 2. So this should give you 5 times root 3 on 2. Yep. And then sine 30 is half, I believe. Yep. So this gives you 5 over 2. So if you write it in component form, it should look like this. 5 root 3. Okay, so V equals 5 over root 3. 5 root 3 over 2. I plus 5 over 2j, like that. That should be your answer. Okay, and then we'll try one last question for this. Okay, so let's find the length. So the length and the angle when they've given the vector, which is negative I minus 2j, right? So this one is the opposite of what we've been doing so far, right? They give us the vector, and I want the length and the angle, right? Previously, they gave the length and the angle, and I want to find the vector, right? So let's think about how we can do this. Okay, so if I just roughly draw this to get a rough idea of what it would be, negative I means I go -1 in the x direction, right? Negative 2j means I go -2 in the y direction. So your vector, you can see -2j, negative I, your vector looks like that. So I'll just draw it in red pen. This is -2j, and then negative I, so your actual vector looks something like this. And you can see the angle you should have is something like this, right? It should be maybe 200 as a guess, right? Okay, so remember how we can find the length. I'll just rewrite it in case you've forgotten. This is the formula for length. The formula for the angle is y over x. That's a lie. The formula for angle is tan theta equals y over x, right? So let's find the length first. So the length of v is x squared. So -1 squared is just 1. -1 squared. And then y squared, so -2 squared. Plus -2 squared. So remember, squaring a negative number it'll still be positive. So -1 squared is 1, -2 squared is 4. So your length is 5, right? Now, if you wanted to find the angle, what you could do is, I could do tan theta, right? So maybe I'll expand this because it's a bit small. Oh, oops. Okay, I'll just draw it again. -2j, negative I. This is this. So this theta here is different from the actual theta I want to find, right? So maybe I'll call it alpha, just to make it clearer. So if we use the formula, I have tan alpha equals to y over x, which is -2 divided by -1, which is just 2. So if you put in your calculator, alpha equals tan inverse of -2, which in this case is 63 degrees 26 minutes, right? That's what this angle is. I want to find this angle, right? So how can I do that? So if I know this whole thing is 270 degrees, because 1 right angle, 2 right angle, 3 right angles, so this is 270 degrees, right? And I know that this is 63 degrees. That means this whole theta is just going to be 270 degrees minus 63.26, right? Negative I minus 2j. Did I do this right? Y2. So when you put this in your calculator, 270 minus 63.26, your answer should be 206 degrees and 34. Okay. Yep, okay. Now we can move on to dot product. So to begin with, I'll just write the rough definition of what dot product is. So dot product happens between two vectors, right? Let's say I have a vector P, which equals to x1i plus y1j, right? And then I have another vector called Q. So don't worry about this looking a bit confusing. These are just numbers, right? So it could be 7i plus 3j, right? Then for q, I could have x to I plus y to y to j. So again, these are just two numbers. Basically, the dot product p dot q would just be x1 times x2 plus y2 plus y1 times y2, right? So your answer would just be like a number, like 73, for example. Okay, so let me just give a quick example. So this is how you would do it in notation form. I mean the, what's it called? Wait, let me just, what is it called? The component notation, right? So if they gave it in component notation, let me give just an example and you can see how it works. So let's say P equals to 3i plus 5j, Q equals to 7i plus 3j, right? And then it asks, what is the dot product? So if I wanted to find the dot product, I can times these two x components, as you can see. You times these two, x1 times x2, y1 times y2, right? So it's simply just 3 times 7. And then you times the two j coordinates together, or the y coordinates, right? So 5 times 3, as you can see. y1 times y2, y1 times y2, right? 5 times 3. It's that simple, right? So 21 plus 15, your dot product will be 36. Okay. It shouldn't be too bad, so I won't go over another example. Let's say I had instead of component notation, I had the column notation, right? So these are the two different ways they could ask you it. So let's say you had P equals to 2, 5, and Q equals to 3, 2, right? So just remember, this just means the same thing as 2i plus 5j, 3i plus 2j, right? So the first number is your x coordinate, the second number is your y coordinate, right? It's going to be the same thing, right? You times the two x coordinates together and the two y coordinates together, right? So these two coordinates I times together, 2 times 3, I get 6. 5 times 2, I get 10. 16, right? Yeah, so it's fairly simple. So in general, it would look something like this. If P equals to x1, y1, and Q equals to x2, y2, then P dot Q just equals to x1 times x2, y1 times y2. Fairly simple, right? Okay. Example 23. Okay. So, oh wait, I should also write the, okay. So you have this formula, which I'll just highlight. So this formula in blue, right? Another formula for dot product is this. PQ is the length of P times the length of Q cos theta. So if you check your formula sheet, these two are actually on your formula sheet, so you don't need to try too hard on remembering it, but it's better if you do, right? So an example of this is, let's see if I can find an example. Actually, it should be fine. Yeah, okay. Another useful kind of result, apart from these two highlighted ones, is if P and Q are perpendicular, so just remember this theta is the angle between P and Q, right? So if P and Q are perpendicular, then your dot product is 0, equals to 0. So P dot Q equals to 0 if they're perpendicular, right? If P and Q are parallel or anti-parallel, so remember parallel is like this, anti-parallel is like this, right? So if they're parallel or anti-parallel, then P dot Q equals to plus minus the length of P and the length of Q. So if I wanted to quickly show you or prove why this is, I'll just draw the cos graph first, right? So if I draw the cos graph, we know it looks something like this. 360, 180, 0, right? So when they're perpendicular, let's say I have a vector P and a vector Q. I can see when they're perpendicular, the angle is going to be 90 degrees, right? Or the angle can also be 270 degrees. Oh wait, 270 degrees, right? If it was something like this. And I can see at 90 degrees, cos theta is 0, right? As you can see, this is at 90, this is at 270. So when they're perpendicular, I can basically say that theta equals to 90 degrees or 270 degrees, right? 270 is not too useful, but I'll just keep it there. Usually it's just 90 degrees, right? So if the angle between the two vectors is 90 degrees, you can see the dot product will be 0, right? Because you basically have the length of P times the length of Q times cos 90, which is just P times Q times 0, right? Cos theta, if you put in your calculator, is 0, as you can see, right? Cos 90, if you put in your calculator, is 0, yeah. If I do the same thing for this second result, so this is the first result, this is the second result. If I do the same thing, parallel means the angle between them is either going to be 0 degrees, as you can see, or it's going to be 180 degrees, as you can see, right? So if I just roughly draw this, this is when theta is 0. This is when theta is 180, right? You can see if when the angle is 0, what does cos theta equal to? Cos 0 equals to 1, right? So P dot Q just equals to length of P times the length of Q. What about when cos theta equals to 180? I can see it equals to -1, right? So you can just roughly see that P dot Q, when theta equals to 0, you have it just equals to length of P times the length of Q, right? P dot Q, when theta equals to 180 degrees, it's just P Q cos 180. And I know cos 180 is just -1, right? So that's where you get, maybe I'll use green. So that's where you get these few formulas from. This, cos 90 is 0, equals to 0. Okay. Okay. All right. So let's just try an example question of using dot product, okay? So, find T such that the vectors x and y are perpendicular. So remember, when it's perpendicular, it means the dot product is 0, right? So this first part, let's say, oh, whoops, it's not working properly. Okay, when A equals to -1, 5, my pen is acting up, okay. When A equals to -1, 5 and B equals to 2t, I basically want to find t when a dot b equals to 0, right? Because that's when the two vectors are perpendicular. So I'll just show you. So remember, dot product is just this thing times this thing, right? The two x coordinates times together. So you basically have -2 plus these two times together. So 5 times t, 5t, and that equals to 0. And I want to solve for what t is, right? So if I move the -2 over, you get this. You get t equals 2 over 5 if I divide both sides by 5, right? So we'll do the same thing for another example, which might be a bit harder. So let's say a equals to 3 minus 2t. Oh, whoops, that's a minus. And then b equals to t squared plus t, and then -2, right? So find t such that a dot b equals to 0. So just remember, since I have t squared, you'll end up with a quadratic. So it might be a bit more difficult, this question. Okay, so let's just go through it. So a dot b, I know, is these two x coordinates times together. So you have 3 times t squared plus t. And then you have these two y coordinates times together, right? So you have -2 times 3 minus 2t, and this equals to 0. So let's expand this and solve for t. So 3t squared plus 3t minus -2 times 3, which gives me -6. And then -2 times -2t, which gives me +4t. And now I can collect the like terms, right? You have 3t and 4t, which gives you 3t squared plus 7t minus 6 equals to 0. Whenever you're left with something like this, to find t, you have to factorize this into its factors, right? So 3, I can factor into 3 and 1. -6, I can factor into -2 and 3, right? So, -3, -2. So you can see -2 times 3 gives me -6. And if I cross multiply, I have 9 minus 2, which gives me the middle number. So I can see this combination works, right? So you get 3t minus 2 times t plus 3 equals to 0. And when I solve for t, this first one, I get 3t minus 2 equals to 0 by the null factor theorem, right? Null factor theorem. So just remember, if you have two kind of things times together, then each of them will equal to 0, right? Because 0 times anything is still 0. So if you search up on the internet what null factor theorem is, if you have two things times together, so a times b, it basically means that a can equal to 0 or b can equal to 0, right? Because if a equals to 0 and b equals to 7, for example, it still equals to 0, right? If b equals to 0 and a is 7, then you're still left with 0, right? So whenever you have like a bunch of things times together, then each of them will equal to 0, right? So if you're not sure, I'll just write like another example. Let's say you had 3x. Let's say you had x plus 7, x minus 2, x plus 1 equals to 0, right? Each of these things would equal to 0, and you would solve for x, right? So as an example, x plus 7 equals to 0, x minus 2 equals to 0, x plus 1 equals to 0, and you can solve x from there. So if x plus 7 is 0, x equals -7. If x minus 2 is 0, x equals to 2. If x plus 1 is 0, x equals -1. So for something like that, you would get 3 different answers, right? And you would write it like so. X equals -7, -1, and 2. So now with this knowledge in mind, null factor theorem, which is kind of previous knowledge, right? We can do this. So you have 3t minus 2 is 0, and you also have, from this one, t plus 3 equals to 0, right? So for this one, If I move the negative 2 over, you get 3t equals to 2. T equals to 2 over 3. For this one, if you move the 3 over, you get t equals to negative 3. And those are your two answers. Yeah. So you can see for question 2, it is a bit longer than for the first one, right? Okay. Okay. So let's use, instead of using this kind of formula, we'll start using this formula a bit more, right? So let me just write it again. You have P dot Q equals length of P times the length of Q cos theta, right? So let me just write an example. Let's say the vector A and the vector B, okay, actually I'll write it like this. The length of vector A equals to 5. The length of vector B equals to square root of 7, okay? And the angle in between A and B is 110. So what is A dot B equal to? Okay, so remembering, oh, I mean, it's up here, so we can just use that formula, right? So A dot B equals to length of A times the length of B cos theta, right? So we're just using the formula. Length of A is 5, length of B is 7, root 7. Cos theta is 110. So put that in your calculator and that should be your answer. Times cos 110. You should have negative 4.52. Yep. Okay. So let's just quickly try another fairly common example. So let's say I'm given a vector A, which is 3, negative 2, B, which is 1, 7. Let's find the angle in between them, right? So this is a bit more confusing, so I'll just go over it. So A dot B equals to the length of, equals to the length of A, the length of B cos theta. That's just my formula, right? So I'm trying to find cos theta. I'm trying to find theta. So let me just subject that for now, right? So I have cos theta equals to A dot B over length of A, length of B, right? So I'm dividing both sides by this. That's why it's on the bottom now, right? So remember A dot B, I simply just have these two things times together. So 3 times 1. So I have 3 plus negative 2 times 7. So negative 14, right? Remember, when you find the length of a vector, it's just this formula from before, right? So if I use the same formula, I'll just write this. So equals to x squared plus y squared. If I use it for A, you have 3 squared. So I'll just write that. So you have 3 squared plus negative 2 squared. For the length of B, you have 1 squared plus 7 squared. And now I can start simplifying it, right? So 3 plus minus 14 is going to be negative 11. And this will give me 9. This will give me 4, right? So 9 plus 4, 13. Here I have 1 squared and 7 squared, which gives me 1 plus 49, so 50. Okay, so you can put that in your calculator and see what, so cos theta equals to that. So we won't put in our calculator yet. So theta just equals to cos inverse of this whole thing, right? And if we put this into our calculator, just remember to keep it in degrees mode, not radians. So 13 times root 50. Your answer will end up being 115.56 degrees. So we can just round it to 106 degrees, nearest degree. And that's how you do something like this. So Definitely these two questions are fairly common, so we should know how to do them, right? Okay. To probably finish off this topic, we'll just go over projection, which is the last kind of subtopic of this topic. So projection formula. Okay, so if you check on your formula sheet, you should have a formula that looks like this. Okay, I should charge my, hold on. Okay, A dot B over B Okay, so you should have that formula, right? So what projection actually means is, you can think of it as like a shadow. So let me just draw like an example. So let's say this is the vector A, this is the vector B, right? This basically means the projection of A onto this lower letter. So projection of A onto B, right? That's what this means. Projection of vector A onto B. So what it means visually is it's basically the component of A that is parallel with B, right? Or in plain English, it's essentially just the shadow cast by A onto B, right? So if you imagine something like there's like a sun, right, above A, if you imagine the shadow that would be created, it would look something like this, right? And then the shadow is this thing. That's basically what projection is, right? So if you have a sun up here, you cast like a shadow, the shadow created would look something like this, parallel with B, right? So if I draw in red, this is projection of A onto B. That's basically what it is. Okay, let me just find like an example. So just a quick example to show how this roughly works. Let's say if I find projection of the vector A, which is 2, 3, onto the vector B, which is negative 3, 5. If I just use the formula, so let me just copy it. So if I just use the formula, I can see at the top I have A dot B, which is dot product, right? So remember, I just times these two x coordinates plus these two y coordinates times together. So you have 2 times negative 3, which gives you negative 6, and then 3 times 5, so 15, right? And this bottom is the length squared, right? So remember the length or the magnitude is x squared plus y squared, right? So the length of B is just going to be negative 3 squared, so 9, and then 5 squared, so 25 squared, times the vector, right? So negative 3, 5. So just be careful. This one, you're finding the actual length. This one, this B here, is the actual vector. I don't turn it into length, right? And you can see I have a square root and a square here, which in this case would cancel out, right? And you're left with negative 6 plus 15, which gives you 9. And on the bottom, you get 34. 34. Negative 3, 5. Right? And that's what your answer for the projection would be. Okay? Yeah. So just remember when you're doing projection, the formula is just these two things dot product together. And this thing on the bottom will just be this lower vector squared And same for this one. It's always the bottom, the lower vector, right? Yeah, so you can see the projection is just going to be a scalar multiple of the actual vector, right? So it shows that it's 9 over 34 times the length of the vector b. So it's parallel to it, right? But yeah, I think that will be the end of the projection. I mean, the entire topic.